I'm Patrick from AITutor, and this is Difficult GCSE Maths Questions, Episode 2. There's no time like the present, so let's crack on. What I've done is I have grabbed a question from the sequences section of algebra. So let's give it a read. It says, the first three terms of a geometric sequence are x plus 56, x and 2x minus 84. Find the value of the positive constant x. Right. What's a geometric sequence? This is a geometric sequence. This is not a geometric sequence. So what's the difference? What happens? What do I do to get from one term to the next here? Well, it looks like I'm multiplying by 2 each time. Now, a sequence in which to get from one term to the next you multiply by a number, and that number is the same each time, is called a geometric sequence. And what this number is, one way of saying it is r, which we like to call the common ratio, which kind of makes sense, right? Because if you think of the ratio of two subsequent terms, it's always going to be the same. For example, if I do the 16 divided by the 8, that is going to be the same as the 8 divided by the 4, which is the same as the 4 divided by the 2. And in each case, I get 2, which is my value of r, which is the common ratio. This ratio is common to all of the terms. That's important, and we'll come back to that in a second. This here is not a geometric sequence. Why is that? Because what do I need to do to get from one term to the next? Well, I could times that by 2, but does that hold on the next ones? It does not. Turns out here what I'm doing is I'm adding 2. This is called an arithmetic sequence. Don't worry about it too much now. The key thing that we want to take from this question is the fact that this is a geometric sequence. We're told it is. So if we're specifically told that this thing is a geometric sequence, then this thing here has to hold. They must have a common ratio. So look at this. The first term is x plus 56. The second term is x, and the third term is 2x minus 84. Look at what I did in this box. Is there anything to tell me that I can't do that exact thing, but with these terms here? Oh no, there's x's in it. Who cares? X's are just numbers. And this is why this question is difficult, because, there's x's in it, it gets a bit confusing. But as soon as you realise, wait a minute, this 2x minus 84 behaves exactly like this 16 does. This x behaves exactly like this 8 does, etc. In other words, the third term divided by the second term, which is what we did here, right? Third term divided by second term, or in that case, fourth divided by third, but subsequent terms. The third term divided by the second term is the common ratio. And that ratio is going to equal the second term divided by the first term. Look at this. We've got an equation, haven't we? Just using the knowledge that this sequence is geometric, so it has this common ratio, I've got an equation. And when I have an equation, I don't want to say the hard work's over, because it's not the easiest equation in the world, but, the tough bit in terms of, what do I do now is over. At least now we know we need to solve this. Right, so every time when we have equations like this, get rid of the fractions. You're never going to be solving an equation if you've got an x on the bottom. So what I'm going to do is I'm going to multiply everything by x to get rid of this fraction on the left. So let's do that. If I multiply the left by x, cancels with the x on the bottom. So I'm just left with that. Multiply the right-hand side by x, just the same as multiplying the top by x. In other words, x times x, x squared. And then don't multiply the bottom by x, because then I just outdo everything. So I keep that as it is. I want to do exactly the same thing now, but with the right-hand side. So I'm going to multiply everything by x plus 56, and it looks like we're going to get some mad numbers here. So 2x minus 84, remember brackets here. Why? Because I'm multiplying the whole left-hand side by x plus 56. I'm going to get equals x squared. Okay, so I think I'm going to get a quadratic equation here. The reason is I've got an x squared here, and then multiplying these out, I'm going to get x squared terms as well. So I'm going to multiply these out. Now, there's probably going to be some crazy numbers in here. I'm going to let you use your calculator for this one, because I don't think they're going to give you, stuff like this in a non-calculator paper. So, what are we going to do? We're going to multiply the first terms of each bracket, so 2x times x, which is 2x squared. We're then going to multiply the outer terms, so 2x times by 56. Well, what's 56 times 2? It's 112. So we're going to get 112 lots of x here. Minus 84 times by x, so minus 84 times by x. And then minus 84 times 56, don't be a hero, straight to the calculator. That is going to be minus 4,704. All of that is going to equal x squared. Okay, obviously there's some crazy numbers flying about here, but remember, we've got a calculator, so just don't let it scare you. I don't think anyone's going to be factorising this straight away, because that'll probably take a while to, find out what numbers you need. Get it all onto one side, clean it up, just stick it in the formula, right? So we're going to take x squared from both sides, so I'm going to get one lot of x squared left, because I had 2 here. In terms of the x's, I've got 112 minus 84 lots of x, which is going to leave me with 28 lots of x. And then this number here is just chilling on its own, isn't it? So that's minus 4,704. All of that equals 0. I mean, if you want to try and be a legend, try and factorise it. I'm out, though. I'm out. I'm going straight into the quadratic formula. So x is equal to minus b plus minus the square root of b squared minus 4ac, all over 2a. All right, we're almost there, kids. So first term, a is going to be the number in front of the x squared, b is going to be the number in front of the x, and c is going to be whatever is left. So we're going to get minus 28 plus minus the square root of 28 squared minus 4 times 1 times minus 4,704. Remember, with the c value, it's not 4,704, it's whatever the sign happens to be. In this case, it's negative. All over 2 times a, which is 2 times 1, which is 2. Okay, I think I'm ready for my calculator here. So what I'm going to do is I'm going to do minus 28, and then I'm going to do plus. Just the plus one. We can't do the plus minus at the same time in the calculator, so choose one of them. Big square root, 28 squared minus 4 times 1 times minus 4,704 all over 2. That is going to get me 56, but remember, we're not done yet because this was a plus minus. So what I'm going to do is I'm going to just get back up to my working on the calculator. I don't have to type everything in again. Go just to the bit before the square root, delete the plus sign, swap it to a minus sign, and I get minus 84. Okay, I've got 2 values of x. It is at this point in any question, look at the question again. So in this case, I've got 2 values of x. Maybe I only want one of them. I can't really remember yet, so I'm going to look at the question just to confirm exactly what they want. And look at this. It says, find the value of the positive constant x. In other words, I've got 2 values, but the question gives me a way to discount one of them. So the value of the positive constant x is obviously the positive one here, which is going to be 56. Always do that, especially if you get multiple answers and you think, wait, I should really only have one here. Okay, so that was part A. I assume now that we have this value of x, part B shouldn't be too difficult. Okay, so part B says, what is the 6th term? Well, we know the first few set of terms, right? We've got x plus 56, x, 2x minus 84. So we've got the first, second, and third. Let's substitute our value of x into these now that we know them, and then we can see how to get to the following terms. So if x is 56, x plus 56 is going to be what? 112. X is obviously just going to be 56. 2x minus 84, let's put this into our calculator. So I'm going to get 2 times 56 minus 84, which is going to get me 28. At this point, can we see a pattern? How do I get from 112 to 56? I half it. How do I get from 56 to 28? I half it. So if this is the first, second, third term, I just need to get a few more terms, don't I? The 4th term is going to be 28 halved, which is 14. The 5th term is going to be 14 halved, which is 7. and then the sixth term is going to be half of 7, which is 7 over 2. In other words, sixth term is just 7 over 2. And that is it.